When you are training clients, it is vital that safety comes first. You will hear us preach this over and over again, safety first. This comes down to selecting the appropriate exercise for the level of your client, selecting the correct starting weight and intensity for your client, and coaching proper technique. All of this falls under the umbrella of biomechanics, which is simply the study of the human body in motion. Our job is to get our clients moving efficiently so as to avoid injury and improve their performance. Having a basic understanding of levers and how force reacts with the body is the first step in understanding biomechanics. Let's look at the mechanics of a bicep curl. This is a bicep curl. I want you to mimic the movement at home and pretend that you have a dumbbell in your hand. These are the key features. The bones, the humerus and the radius, are known as the rigid levers. The elbow joint is known as the fulcrum or the axis. The dumbbell is the load or the resistance. The biceps brachii muscle, which attaches at the shoulder and the radius, exerts the effort. When the biceps muscle pulls on the radius, the force of the contraction of my biceps pulls the lever and therefore moves the dumbbell. Throughout the body, we have many examples of these types of lever arrangements that cause movement. Sometimes the arrangement makes a movement easier, or what we call a mechanical advantage, or sometimes it makes it harder, which we call being at a mechanical disadvantage. Let's explore another example using the shoulder dumbbell lateral raise. In this position, the load is at the end of a very long lever. The distance between the shoulder, the fulcrum, and the load is called the resistance arm. The longer the resistance arm, the more effort is required and the harder it is to move the load. In this example, I am at a mechanical disadvantage. However, if I reduce the lever length by bringing my load closer to the fulcrum and therefore shortening my resistance arm, it is easier. Put simply, the closer the load is to the fulcrum, the easier it is to move. And that is why shorter, stockier people find it easier to move heavier loads than long, lanky people because of their shorter levers. In order to explain the force arm, I will use the bicep curl example again. The force arm is the distance between the fulcrum and the muscle attachment, or this area indicated. Clearly we cannot move the muscle attachment in our body, but it does explain why some movements are easier than others once we understand muscle attachments. If the force arm is short, it is going to take a lot of force to move the lever. If the force arm is long, it doesn't require as much effort to move. So for example, if the biceps attached here, down the radius, it will take hardly any effort at all to move the load.